So let's start today's session. Today we will talk about nuclear and particle physics assignment 9, week 9. Okay. So let's start. So there will be some questions obviously related to the previous year assignment question paper. So first question is, given that E vector equals to minus grad phi minus delta del t, A prime equals to A plus grad lambda and phi prime equals to phi minus del lambda del t. So they are asking that which of the following is or are correct, and here lambda is a scalar function. Okay. So this is the question, and they are asking that what will be the answer for this. Let's start for that. You can see here in that question, like in the left hand side, all the terms are in, it is in the terms of E only. But in the right hand side, you can see it is in the terms of phi prime, A prime. So obviously we have to change our phi to phi prime, A to A prime to get the answer A, B, C or D. So for that, what we will do, we can just first write the expression whatever it is given. E equals to minus grad phi minus del A del D. Okay. And then phi prime equals to phi minus del lambda del D. Whatever it is given here, I am going to write that. And then A prime equals to A plus grad lambda. Okay? A plus grad lambda. So, let me write here phi. Phi will be phi prime plus del lambda del T. And what will be A? A will be A prime minus grad lambda. So, grad phi will be grad phi prime plus grad of del lambda del T. Okay. Similarly, for A, del A del T will be del A prime del T minus grad of del lambda del T. Now, if I just put the values of grad lambda, whatever it is given here, and the value of del A del T in the expression of E, then what we will get? We will get minus grad, okay, see it is grad phi, so grad phi means it will be grad phi prime plus del of del lambda del T minus del A prime del T minus grad of del lambda del T. Okay. So now it will be minus grad phi prime minus del of del lambda del T minus del A prime del T plus grad of del lambda del T. Now you can see this is plus and this is minus. So it will be like minus grad phi prime minus del A prime del T. So this is E. Now we got to know in terms of the phi prime and A prime, the expression is like this one. So now let's check the option which one is the correct option. Minus grad phi prime minus del A prime del T. So here we can see the expression is equation number B. E equals to minus grad phi prime minus del A prime del T. Okay. Now we are going to the next question. Given the field tensor F mu nu. Okay. So let me write here F mu nu is equals to del mu A nu minus del nu A nu. Which of the following are invariant under Lorentz as well as the gauge transformation? Okay. So first of all, what is here the gauge transformation function? The gauge transformation function is A mu prime equals to A mu plus del mu lambda. Right. So under this transformation, which one is invariant? If one will be invariant under this transformation, then that will give us a gauge transformation. But if it will not be under this under this transformation, if it is not invariant, then that will not give the gauge transformation. And what about Lorentz transformation? I will tell that one a little bit later. So we will call one by one. So first of all, if mu nu, if mu nu, I can write it like del mu a nu minus del mu a mu, right? So that we can write. So if it is like that and a mu prime is like a mu plus del mu lambda, so if mu nu, so I'm just if mu nu prime under Gauss transformation I'm first talking. So under Gauss transformation, what will be the answer? It will be like del mu a nu prime minus del mu a mu prime. So it is del mu a nu because it is nu index and it is a nu index. So it will be replaced by nu. Nu will be replaced by nu here plus del mu lambda minus del mu a mu plus del mu lambda. So let me write here del mu a nu plus del mu lambda del mu a mu minus del mu lambda. Okay. Now you can see here, if I write del mu a mu minus del mu a mu, then plus del mu lambda minus del mu lambda. And obviously mu and mu both are the domain dishes, so they can be interchanges. Okay, so they can interchange, so that means del mu lambda can be written as del mu lambda, right? So for this case, if mu will be del mu a mu minus prime del mu a mu plus del mu lambda minus del mu lambda. So obviously you can see that will cancel out and it will be exactly whatever it is it was given as if mu. So under this Gauss transformation, whatever it was there, a mu prime will be a mu plus del mu lambda. Under this transformation, if mu prime is equals to if mu. So under Gauss transformation, if mu is invariant. Okay. But in that question, they are asking that what will be for this if it is Lorentz invariant or gauge invariant as well as gauge invariant. So obviously we have seen that is gauge invariant, there is no problem. But we have to check that it is a Lorentz invariant or not. So to check the Lorentz invariant or not, so what is there? Like obviously if it is scalar, then it remains same under Lorentz invariance. Lorentz transformation actually. So what does this means? Transformation. Like we have to check that whatever the quantity is given here, if mu that is under Lorentz invariant or not. So for Lorentz invariance, if it is a scalar term, then obviously it will be Lorentz invariance. But if it is a tensor term, tensor of rank 1 or rank 2, rank 1 means it will be a vector, rank 2 means it will be a tensor. So for these cases, it will not be the Lorentz invariance case. So obviously if mu is a field tensor, we know that it is a field tensor of rank 2, right? So if it is a rank 2 tensor, so that means it is not invariant under Lorentz transformation, right? So for if mu case, we have seen that is Gauss transformation, invariant under Gauss transformation, but not in Lorentz transformation. So this is for if mu case. Now coming to the second option. For second option case, there was a second option which is if mu a nu. So let me write this one here. F mu nu, A mu, A nu. So to check that it is gauge invariant or not, or Lorentz invariant or not, first of all, this one is tensor. This as a whole is scalar. Now check the gauge transformation. So what will happen if it will be that quantity and it is under the gauge transformation, what will be happening? So for gauge transformation, that is like this one I will write. And for gauge transformation it was A mu plus yes, del lambda, sorry, del mu lambda. So now and also we have checked that F mu nu prime is equals to F mu nu. So what we will do for this case, we will just write here F mu nu and then A mu prime. A mu prime means A mu plus del mu lambda into A mu plus del mu lambda, right? So now F mu nu, then A nu plus this del mu lambda, A mu plus del mu lambda, del mu lambda. Now one thing is that this is but A mu del nu lambda is symmetric. So what does this mean? This means that if I write here A mu del mu lambda, that can be del mu lambda A mu. So if I just replace this one, then you can see here from this expression F mu nu, then A mu plus, okay, so first of all A mu del mu lambda, let me write here whatever it is there. Now del mu lambda A nu, so I can change it like A mu del mu lambda, because again the mu and nu are the dummy indices. So now del mu lambda and del mu lambda. But the main problem is whatever the previous expression was there, that was del mu, A nu. But right now, if mu prime, A mu prime, del A nu prime, that is not equal to this one under gauge transformation, right? Because there is this term extra, this term extra, this term extra. So obviously it is not equal to F mu, A nu. And as it is not invariant under gauge transformation, so obviously we will not see the next one, that whatever it is given, is it Lorentz invariant or not, because its gauge invariant is not satisfied. So obviously this will not fit in that question, that which of the following are Lorentz invariant as well as the gauge transformation invariant. Okay. So now come to this next one is F mu nu, F mu nu. So for this case, let's say for gauge transformation. For gauge transformation, F mu nu prime, F mu nu prime. Now we have already checked that F mu nu prime is equal to F mu nu. So obviously F mu prime, F mu prime should be equal to F mu, right? So under gauge transformation it will be invariant. So let me write here invariant under gauge transformation, right? Now coming to the Lorentz transformation, this is as a whole a scalar quantity. So under Lorentz transformation, obviously it will be invariant, as I have already mentioned in the previous case. So for the C option, F mu nu, this is gauge invariant as well as Lorentz invariant. Okay. Now coming to the fourth option. Fourth option was mu. So let me first check that gauge invariant mu prime, and also it is written that mu equals to del mu, mu prime equals to mu plus del mu lambda. Okay. So here we can write mu plus del mu lambda into mu plus del mu lambda. So you can see here mu del mu lambda plus del mu lambda mu plus del mu lambda del mu lambda. Again the same thing, that mu del mu lambda, that is symmetric. So I can write it like mu plus 2, let's say mu del mu lambda plus del mu lambda del mu lambda. But the main thing is that this is not equals to mu. So this quantity is not invariant under Gauge transformation. So obviously, as it is not Gauge transformation invariant, so obviously we will not go for the Lorentz transformation or otherwise. But if we will check, then obviously this is a scalar function, so that will be fine for Lorentz transformation. But as it is not a invariant under Gauge transformation, so this will not be the correct answer for this question. So the correct answer for this question will be this one only, that if mu, this is invariant under LT as well as GT. Okay. Yes. So this is the question. Given the components of the electromagnetic field tensor F0 equals to minus Ci, the component F0 to delta is how much? So first of all, F mu, this is for EM theory, and then it has a expression this one, right? Now what is this one? This one is well tension, right? So what does this mean? The expression, I mean obviously there should be relation between this one and this one. The relation is like if mu tilde is equal to half of epsilon mu, let's say alpha beta, f alpha beta. Okay. Now we can see I have written this one. So what will be this one? This one will be simply right. So this one will be simply eta del mu nu minus del mu mu. So we'll just put these values, and obviously epsilon, mu, nu, alpha, beta, these are the Lewis-Vita tensor, right? Symbol. So I think you all know the properties, like let's say 0, 1, 2, 3, that will be plus 1, and if it is a cyclic permutation, then that will give a plus 1, and antisymmetric, symmetry will be there, then it will be 0, 1, 2, 3. So if it is 0, 1, 2, 3, that is 1. Let's say 0, 2, 3, 1, and let's say 0, 2, 1, 3, that is minus 1, and similarly 0, 2, 1, 3. Oh, okay, that is same exactly. So it will be like 2, 0, 1, 3, that will also be minus 1. And if it is like mu, nu, alpha, beta, any of them, like let's say alpha and beta are same, then obviously epsilon will be 0. Or let's say mu and nu are same, or mu and alpha same, or mu and beta same. So these all combinations will give us the value of Lipschitz symbol as 0. So if mu nu tilde, it is mu nu alpha beta if alpha beta, right? So in that question they were asking if 0 to tilde. So let me write here, if mu nu so 0 2, that means mu equals to 0 and nu will be 2. So half epsilon 0 to alpha beta if alpha beta. Now here 4 indices are possible, like 0, 1, 2, 3. So that can be written as epsilon 0 to, like alpha and beta value can have 0, 1, 2, 3. But here obviously, as I told that any of them are same, then obviously it will give the 0 value of Lipschitz symbol. So alpha and beta value can have only 1 and 3. If it is 0, then also it is 0. If it is 2, then also Lipschitz will be 0. So half epsilon 0 to 1, 3, if 1, 3, and also one more thing can be possible, 3, 1. Okay, so these two can be possible, 0 to 1, 3, if 1, 3 plus 0 to 3, 1, if 3, 1. So if it is like that, then I can write 0 to 1, 3, 0 to 3, 1, this, right? So now if 0 to 1, 3, 0, 1, 2, 3 is plus 1, 0 to 1, 3 is minus 1, so 0 to 1, 3 will be minus 1, but again 0 to 3, 1 will give a plus 1, and epsilon 0 to 3, 1 is plus 1. So if 0 to tilde will be like 0 to 1, 3, that is minus 1, so that means minus f1, 3. Then minus, why minus? Because 0 to 3, 1, that will be plus, 0 to 3, 1 is plus, so f3, 1. So it will be, the answer will be minus f1, 3 plus f3, 1. Now what is the value of f1, 3 and f3, 1? If alpha, beta, whatever it is there, it is antisymmetric. So if alpha beta is equal to minus of f beta alpha. So if I write here f0 to tilde, so it will be like f13 minus of f31. So 1, 3. Because for this case f13 equals to minus f31. So if I just write f31, then obviously it will be minus of f13. So it will be minus f13 only. Now what is the value of f13 for this case? If I write the expression of f mu mu, then it is like 0 ex by c, ey by c, ez by c, minus cx by c minus cy by c minus cz by c. Then this is 0, 0, 0. This is minus bz, bz minus by, by minus bx, bx. And how it is counting? It is counting as 0, 1, 2, 3. Here again 0, 1, 2, 3. So they are asking F13. So F13 means this is 0 throw, this is 1 throw. So 1 throw and then 0, 1, 2, 3. So that means by. Okay. So the answer will be like minus by. And by means obviously bx we will write it as b1, by is b2, bz as b3, like that. So F02 is by, it is minus by. So the answer, whatever it is given, so this one, F02 tilde. One three three one 2 1 minus 1 3 F13. Okay, and F13 is 0 1 0 1 2 3. Okay. So yes, so here F10 is 0, F20 is 0, F03 is minus 4 in appropriate units. So obviously we will not take care about the units right now. Which of the following may represent the 4 vector potential? T represents time and Z represents the Z component of position vector. So let me first write here F mu expression. In the matrix form, if I want to write, the matrix form, it will be like the uppercase, right? It will be okay. One more thing is there. If yes, so F mu can be written as eta alpha nu, F beta alpha, eta mu beta. So alpha alpha, then beta beta, nu nu. Okay. So it is if alpha beta is there. So obviously if I mean superscript and subscription are related with this expression. So if I am getting this expression, this one, F mu nu, then we can obviously get F mu nu in the upper script as well. So the answer will be like 0 minus x by c minus cy by c minus z by c. Then it is ex by c, ey by c, ez by c, then 0, 0, 0. It is minus bz, this is bz, this is minus by, this is by, this is minus bx, this is bx. So this is F mu expression. Now, it is given F10 equals to 0, F20 equals to 0, and F03 equals to minus 4. So F10 means what? This is 0, 1, 2, 3, 0, 1, 2, 3. Right? So F10, that means 1, 0. This one. Ex. So Ex by C is equal to 0. That means obviously Ex is 0. Now coming to F20. 20 means this one. Ey will be 0. And then F03. F03 means 0, then 1, 0, 1, 2, 3. So minus Ez by C. Minus Ez by C is equal to minus 4, because it is already given here, this one. So I can write it like Ez is equals to 4. So we can see Ex is 0, Ey is also 0 and Ez is 4. So what is the value of E vector if I write Ex I cap plus Ey is a cap plus Ez k cap, so that will give us only 4 k cap. Yes? So if I write here 4 z cap, that can also be possible. Now they are asking that what will be the expression for the 4 vector potential. So let me write here this option first. So this expression means let me write here this is A mu. This A mu means A mu can be written as info momentum as phi A1, A2, A3. So for this case phi is 0, A1 0, A2 0 and A3 is minus 4t. Now our E expression is minus grad phi minus del A del t. So as phi equals to 0, so that will be 0 minus del t of A. A means obviously here A1 I cap plus A2 j cap plus A3 k cap. But as A1 it was 0, so it will be simply minus 4t k cap. So now you can see this is minus, it will come as plus, and then 4t, this is 4 k cap. So for this case, if our A mu is 0, 0, 0, minus 4t, then our E vector is 4z cap, and obviously I can get this one as well. So the option number A is the correct option to get the 4 vector potential. Now coming to second option, 2z 0, 0 minus 2t. Two z 0, 0 minus 2t. So what does this mean? This means that our phi is 2z, A1 is 0, A2 is 0, A3 is minus 2t. So again E is minus grad phi minus del A del t. Now grad phi, okay? So phi is like minus del z of 2z k cap minus del t of minus 2t, and obviously if it is A3, so there will be a k cap, so it will be minus 2 k cap plus 2 k cap, right? So it will give us a value 0, but we are having E as 4 z cap, like 4 k cap, so this will not be the correct option, right? So option number B is not correct. This is not correct, right? So now come here, 0, 0, 0, 4t. Obviously we have seen that 0, 0, 0 minus 4t is the correct one. So 0, 0, 0, 4t will not be the correct one. Now come to this one, minus 4z 0, 0, 0. So here we can see our phi is minus 4z, but A1 is 0, A2 is 0 and A3 is also 0. That will be in superscript obviously. So what is expression of E? Expression of E will be minus grad phi minus del A del t, and del A del t will give you 0 obviously because A1, A2, A3 all are 0. So only minus grad phi will be there. So E is minus grad phi. Now so it will be like minus del z of minus 4z k cap. Now you can see it is 4 k cap. So we can understand that if our A is like 0 0 0 minus 40, then also we are getting E as 4 k cap, and if it is like minus z 0 0 0, then also we are getting E equals to 4 k cap. So the correct option should be like A as well as D. Both these two options are giving the correct expression for E, whichever we are getting from these. Ex is 0, Ey is 0, Ez is 4. So E is 4 k cap. Okay. Now maybe this one. Given f10. The same similar question is there. f10 is 4, f20 is 4, f03 is 0. Then which of the following will represent the 4 vector potential, where t represents time and z denotes the z component of position vectors. Right? Okay. So similarly, f10 is 4, f20 is 4, f03 is 0. So let me write here again what is f10 means. Minus ex by c minus ey by c minus ez by c, then ex by c, ey by c, ez by c, 0 0 0. Here it is minus bz, bz, by minus by minus bx, then bx, right? So now f10, so this is 0, this is 1, so 1 0, that means ex. So ex they are given as 4. Now f20, 0 1 2, so ey also they are given as 4. And f03, that means 0 1 0 1 2 3, so it is minus ez by c, that is 0. So now what is in our E vector right now? Our E vector is like EXI cap plus EYJ cap plus EZK cap. So the answer will be like 4I cap plus 4J cap plus 0K cap. So it is like 4 into I cap plus J cap. Okay. So this is E vector. Now let me see here. Minus red phi minus del A del D. Okay. So option number A. Mu is how much? Mu is, it's already written 0 minus 4x minus 4y 0. So for this case, phi is 0, a1 is minus 4x, a2 is minus 4y, a3 is 0. E is, it is 0 minus del t of minus 4x I cap minus 4y j cap plus 0. So you can see here, okay, so this is 4x, this is 4y, so that will not be derivative with respect to t, right? So that is obviously giving us 0. So the first option is not the correct option. Now coming to B option. 0 minus 40 minus 40 is 0. 0 minus 40 minus 40 0. So E is again minus del phi minus del A del T. So for this case our phi is again 0, but now A1 is minus 40, A2 is minus 40. So if I write here, then our E will be 0 minus del T of A vector. A vector means minus 40 I cap minus 40 j cap plus 0 k cap. So now you can see minus minus it will come as plus. So 4 I cap plus 4 j cap. So which will give us 4 I cap plus j cap. Okay. So now our E will give us 4 I cap plus j cap, whatever it should be. So the option number B is the correct option to give this type of electric field and this type of 4 vector potential. Now coming to C, minus 4x minus 4y 0 0 0. So for this case, phi is minus 4x minus 4y, a1 is 0, a2 is 0, a3 is 0. So obviously we will not directly care about a vector anymore. So only E minus grad phi minus del A del T, and now minus grad phi we will only take care. So minus grad phi means what? Del, let me write here, del x of phi I cap plus del y of phi j cap plus del z of phi k cap. So if I write here phi was minus 4x minus 4y, so it is like only with respect to x it will survive, so it is minus 4 I cap. It will survive with respect to y only, so it will be minus 4 j cap, and it will not survive because it is with respect to z only, so that is 0. So the answer will be like 4 I cap plus j cap. Then you can see that this is again the correct one, whatever we want. Okay. Now coming to the option number D. For option number D, it was minus 4x minus 4y minus 40 0. Okay. Mu is minus 4x minus 4y minus 40 0. So for this case, phi is minus 4x minus 4y, a1 is minus 40, a2 is minus 40, a3 is equal to 0. Right? So our E is minus grad phi minus del A del T. So if I write that one, then minus del x of phi I cap plus del. Actually, it should be in the front. It should be like that. Del x of phi minus del T of a1 I cap plus del T of a2 j cap plus del T of a3 k cap. So you can see here phi is minus 4x minus 4y, so it will be like with respect to x only, it will give us minus 4 I cap. Now coming here, oh, this is y, this is z, sorry. So with respect to y, it will be like minus 4 j cap. With respect to z, it is nothing because there is no component of z in phi, so it will be 0. Now coming to here, del T of a1. So a1 is how much? a1 is minus 4. So it will be minus 4 I cap. Then minus 4, a2 is also minus 40, so it will be minus 4 j cap, and then it is 0. Now you can see this is 4 I cap plus 4 j cap, again plus 4 I cap plus 4 j cap. So it is like 8 I cap plus j cap. So that is not the correct one, because our answer of E is 4 of I cap plus j cap, as we have got from this expression. So the correct option for mu is this one and this one. These two are the correct option when f10 is 4, f20 is 4, f03 is 0 in appropriate units, and the B and C option are the correct for vector potential, where T represents time and Z denotes the Z component of position vector. And obviously X and Y are the similar one. X represents the X component of position vector, and Y represents the Y component of position vector. Okay, fine. So yeah, so this is the sixth question. Now we'll talk about sixth question. Consider the 4-vector potential A mu is equal to epsilon mu e to the power I q dot x, with epsilon mu is equal to 1 by root 2, 0, 1, minus I 0, and q mu equals to root 2 e 0, 1, 0, 0, 1. Define the electric field associated with this as EI equals to real of Fi0. That is, if Fi0 is complex, take only the real part as the components of the electric field. Which of the following is the correct expression for the electric field corresponding to the given vector potential? And note that q dot x means q mu x mu. That means they are asking that q dot x, if we will talk, then it will be 4 momentum dot product. So whatever it is given here in that question, we will just quickly write. A mu is given as epsilon mu e to the power I q dot x. So as they have already mentioned, q dot x means see, this is a 4 momentum dot product. So q mu x mu. So I can write it like I q mu x mu. Okay. And also whatever else given here, epsilon mu is given and q mu is given. So epsilon mu is how much? Epsilon mu is 1 by root 2, 0, 1, minus I 0. So this means that epsilon 0 is 0, epsilon 1 is 1 by root 2, epsilon 2 is minus I by root 2, epsilon 3 is again 0. And what is the expression for q mu? Q mu is given as root 2 e 0, 1, 0, 0, 1. So this means q0 is root 2 e 0, q1 is 0, q2 is 0, q3 is root 2 e 0. Now, how to what they are asking? They are asking that what will be the expression for electric field. So how to calculate electric field? Electric field is a real part of Fi0. So if by any chance we can calculate the value of Fi0, the real part of Fi0 will give the value of Ei. So if I can get Ex, Ey and Ez, then obviously we will get to know that what will be the value of E vector, because E vector is E1 I cap plus E2 j cap plus E3 k cap. Okay. So first of all, our main aim is to find Fi0 and then Ei0 is equals to real part of Fi0. So Fi0 means what? If mu nu is del mu a nu minus del mu a mu. Yes. So if I just replace mu by 0 and mu by I, then it will have f0i, it is like del, Fi0, sorry. If I0 equals to del I A0 minus del 0 Ai. Okay. Now A0. A0 is what? Okay, let me expand this one. A mu equals to whatever it is given. A mu is epsilon mu e to the power I q dot x. So A0 is like epsilon 0 e to the power I q dot x, and then AI is epsilon I e to the power I q dot x. Now epsilon 0 has the value as 0. So A0 will give the value as 0 also. So Fi0 was del I A0 minus del 0 Ai. as a0 is 0, so we can see this is 0 minus del 0 ai. Okay, so if I0 is nothing but del 0 ai, and del 0 means like del t of ai. Now what is ai? Ai is epsilon I e to the power I q dot x. So if I0 is equal to minus del t of epsilon I e to the power I q dot x. Okay. So now we will expand that q dot x. Q dot x means q mu x mu. It can be written as like q0 x0 minus q vector dot x vector, right? So now q0 is how much? q0 it is already given somewhere. q0 is root 2 e0. So let me write here root 2 e0, and x0 is what? x0 is t minus q vector x vector. This is again q dot x. So fi0 is minus del t of epsilon I e to the power I q dot x. Now if I just expand that one, e to the power, see this one, I root 2 e0 t minus q vector dot x vector. Why I did that one? Because here epsilon I is just a constant. So epsilon I will come out, and del t of this one, and here only the t is given here. So it is like I root 2 e0, then e to the power I root 2 e0 t minus q vector dot x vector, right? So now root 2 e0 t minus q dot x, this is nothing but q dot x. So we will replace right now this one as e to the power I q dot x. So it means I root 2 e0 epsilon I cos q dot x plus I sin q dot x. I can write it like that. Now minus I root 2 e0 epsilon I cos q dot x. Here you can see this plus, this is minus, it will be minus, and I will give us minus 1. So it will be plus root 2 e0 epsilon I sin q dot x. This is the expression for fi0. Now what is ei? Ei they have given as, you can see from this question as well, ei is real of fi0. So let me write here real of fi0. You can see here in that fi0 expression, this is real part, this is complex part. So the real part of this one that will be the root 2 e0 epsilon I sin q dot x. Okay, so we got the expression for ei as root 2 e0 epsilon I sin q dot x. Now e1. e1 is root 2 e0 epsilon 1 sin q dot x. So now what is epsilon 1? Epsilon 1 is given here as 1 by root 2. Epsilon 2 is minus I by root 2. Epsilon 3 is 0. Okay, so epsilon 3 is totally 0. So epsilon 2 is minus I by root 2. epsilon 1 is 1 by root 2. So if E1 is like root 2 E0 into 1 by root 2 sine q dot x. So it is E0 sine q dot x. Now coming to E2. E2 is root 2 E0 epsilon 2 sine q dot x. So root 2 E0 minus I by root 2 sine q dot x. So it is minus I E0 sine q dot x. And for E3 is root 2 E0 epsilon 3 sine q dot x. Epsilon 3 is epsilon 3 is 0. So if epsilon 3 is 0, that means E3 is 0. So now E vector will be E1 I cap plus E2 j cap plus E3 k cap. So E1 is E0 sine q dot x then this is I cap minus I E0 sine q dot x j cap plus 0 k cap. So the answer of E vector is like E0 then sine q dot x I cap minus sine q dot x and here it will be 1 I and then j cap. So let me see the answer here. So sine, actually E vector will be like whatever this will be there, E0 will be there and then x cap means basically I cap and this is j cap and there will be one minus sign because one is plus and another one is minus. So something is plus and something should be minus. Okay. So here it is like that. Okay. One more thing was there. Actually, yes, this one. Yes. So Fi0, if I write here Fi0, then Ei is this one, right? So let's say E1 is how much? E1 is real of minus I root 2 E0 epsilon 1 cos q dot x plus root 2 E0 epsilon 1 sin q dot x. Now we can see epsilon 1 is 1 by root 2. So this is real. So if it is real, that means this will be real and if this is complex. So real of this whole function will be simply root 2 E0 1 by root 2 sin qx. So E1 is this one, that is very good. But for E2, this one, right? So now E2 you can see epsilon 2 is again a minus 1. So the final answer was Ei was real of for some time. Let me see first. So for E2 we can write here real of f20, and real of f20 means you can see f20 is how much, real of minus I root 2 e0 epsilon 2. Epsilon 2 is minus I by root 2 cos q dot x plus root 2 e0 minus I by root 2 sin q dot x. So for this case, you can see this is not longer a real part. This is a real part. This is minus minus plus and I square is minus 1. So this will be like E2 is like minus root 2 will cancel out E0 cos q dot x. So E2 will be minus E0 cos q dot x. Why? Because here epsilon 2 is again a minus value. I value. So E2 will be minus E0 cos q dot x. So this is not the correct one because I did not see that there is a epsilon 2 as a imaginary one. So the answer is like answer is like whatever E1 was there, that is actually okay. So here it will be like E0 sin q dot x I cap plus, it will be not plus, it will be minus E0 cos q dot x j cap. Why? Because we have already seen here E2 is minus E0 cos q dot x. So it will be like minus E0 cos q dot x. So the answer will be like E0 into sin q dot x I cap minus cos q dot x j cap. Okay, so this is the final expression for E vector. So this one was the final expression, that E0 sin q dot x I cap minus cos q dot x j cap. Actually here one minus sign will be there because of that epsilon 2 value as
Your PPT is not same.
oh sorry
Sure.
sorry, I was disconnected, so that's why. every time it is getting disconnected automatically. So, right. I think now it is visible. Again, it is not visible. Every time whenever I do the screen share, it is going disconnected. Every time I will just share. finish that one, and after that we will actually if the recorded function will be there, at least you can see that one. Whenever I'm just going to connect it is automatically disconnected from my side. So it will finish that one, and if there is any question and doubt, you can just send me in the YouTube Dropbox. We can YouTube chat box. We can talk there. So now question number 7. Consider a reaction E minus C plus going to mu minus mu plus increase in electron and positron annihilate each other, and a muon and antimuon are created. Here the form momentum of these particles indicated by the subscripts are Pe minus, Pe plus, P mu minus, P mu plus. Which of the following delta functions correctly indicate the energy momentum conservation in the reaction? Maybe I can check once again if it is connected or not. No, it is not connecting, so it's better to just record that class, and after that you will see that. Okay, and P minus P plus P E minus P E plus P mu minus P mu plus. Which of the following delta functions correctly indicate the energy momentum contribution in the reaction? So in that reaction is E minus E plus E minus E plus mu minus mu plus. So this type of reaction, it should be energy momentum conserved, right? So for energy momentum conservation, obviously like if I write here E plus E minus going to mu plus mu minus, so it should be like Pe plus Pe minus is equals to P mu plus P mu minus, right? Otherwise the energy momentum will not be conserved. The initial total momentum, the final total momentum should be same. So the delta function will tell us that the energy momentum is conserved. That means Pe plus Pe minus minus P mu plus minus P mu minus should be equal to 0, right? So this is the delta function expression. That should be the correct delta function expression for the energy momentum conservation for this nuclear reaction. As our initial momentum was Pe plus Pe minus, and the final momentum is P mu plus P mu minus. Okay. So now you can see here the options. First one is Pe minus Pe plus. Okay, so I told that delta for Pe plus Pe minus minus P mu plus minus P mu minus. So that should be equal to that is the correct one, and that should be the that should give the energy momentum conservation law for the delta function, right? Now in that equation number A, option number A, you can see Pe minus is there, Pe plus is there, but with a different sign. So that will not give a delta function potential for correct delta function for energy momentum conservation of E plus E minus into A plus B minus reaction. And also we know that delta function delta for x is equal to delta for minus x. So what does this mean? This means that I can write it as like minus Pe plus minus Pe minus plus P mu plus P mu minus. immediately decrease the energy momentum conservation in the reaction. Okay. So now question number 8, we need to write here the last question of this class. The form momentum of a particle is p mu. P mu is E, P, P, where E is its energy and gamma P. Let me join with the students. Actually I was having too much internet problems, so maybe now it will be solved. Let me check. Now I can see it. Okay. So yes, so where we were here, question number 7. Consider the reaction E minus C plus going to mu minus mu plus, in which an electron and positron annihilate each other and a muon and antimuon are created. Let the form momentum of these particles indicated by the subscripts are Pe minus Pe plus P mu minus P mu plus. Which of the following data functions correctly indicate the energy momentum conservation in the reaction? Okay. So for this case, what we will write, we will just firstly draw the Feynman diagram. That is like that, E minus P plus mu minus mu plus. So for this case, if we have to know that the energy and momentum should be conserved in any nuclear reaction. That like momentum conservation means what? Momentum conservation means the initial momentum was Pe minus plus Pe plus, and final momentum it is like Pi. And what about Pf? Pf is P mu minus plus P mu plus. Okay. So these two should be equal. So for the delta for momentum conservation rule, we can have that delta 4 of Pi minus Pf. This will give the energy momentum conservation delta function. Okay. So here we can see delta 4 of Pe plus Pe minus minus P mu plus minus P mu minus should be the correct one. But obviously again we know that delta 4 x is equals to delta 4 minus x. So if I can write it like that, then we can also write it like delta 4 minus Pe plus minus Pe minus plus P mu plus plus P mu minus. Okay. So these two are the correct one because these two are same exactly. So these two are the correct one for energy momentum conservation of this reaction in the reaction. So now coming to the correct option. Actually the main thing we have to check here, Pe plus Pe minus both will have the same sign. P mu plus and P mu minus both will have the same sign. Now here E minus E plus. E minus is plus, E minus is negative. E minus has positive sign, E plus has negative sign. Although obviously it will not give the correct energy momentum conservation in the reaction. Now coming here, mu plus mu minus are both are positive. Mu E plus E minus both are negative. That is fine. Mu plus mu minus both are different, so it is not again. E plus E minus both are again negative, so that is also not correct. So the option number B is the only one which will give the correct answer. Okay. Okay. So now coming to the last question for this session, the form momentum of a particle is P mu. P mu is equals to E P P P, where E is its energy.
Excuse me, ma'am. Please question number 7 show once again. Okay, the form momentum of a particle is just check here in question number 7 that whenever the initial particles are there, they should have the same sign, and the final particle will should be the same sign. So that is the main thing to see in this question. For this question, option number B, you can see mu plus and mu minus have the same sign in that This is also this is also positive, this is also positive. For E plus N minus, both are negative. So that is fine. Okay, now force momentum of particle is P mu is E P P P. P P P means obviously P is the magnitude of the straight dimensional linear momentum. The mass of the particle is m. If psi is the wave function representing this particle, which of the following corresponds to the Dirac equation satisfied by psi? And there are 4 options regarding that. So P mu, let me write here P mu. P mu is like it is given P E P P P. Okay. So what does this mean? This means that our P0 is E, P1 is P, P2 is P, P3 is P, right? So now Dirac equation. So in the context of P, the Dirac equation can be written as gamma mu P mu minus m of psi is equal to 0. So gamma mu P mu. So gamma mu P mu means what? If I just expand this one, so gamma 0 P0. Now here obviously you know that this is P covariant. So covariant means obviously it will be minus gamma I Pi minus m, then again psi equals to 0. So if I can write it like that, then gamma 0 P0 minus gamma 1 P1 minus gamma 2 P2 minus gamma 3 P3 minus m psi is equal to 0. Okay. So here we got that P0 is E and P1 is P, P2 is P, P3 is P. So if I just put all these values, then gamma 0 E minus gamma 1 P minus gamma 2 P minus gamma 3 P minus m whole of psi equals to 0. Now see here, okay, this is gamma 0 E minus gamma 1 P minus gamma 2 P minus gamma 3 P minus m as a whole, it should be psi at 0. So this is the correct option. Now let's check if our P mu is like E0 0 P. Let's see. So this means our P0 is E and P3 is P. So here only P1 and P2 are not there. So that will correspond to this one, because gamma 0 E minus gamma 3 P minus m should be equals to psi equals to 0. But let's say if I have E P 0 0, so it will be this one, gamma 0 E minus gamma 1 P minus m psi equals to 0, because here this is corresponding to the gamma 1 term. This is P1. So this is the case. So the option number D is the correct one here. So maybe I am just going one by one from the very beginning, because there was a little bit problem in the internet connection, so that you can see the answer as well as the question. If you have any doubt, you can ask me. So this is the first question. E was minus this. Which of the following is or are the correct one? And we got the option number B was the correct one. And given the field tensor F mu nu equals to del mu nu minus del nu mu, which of the following are invariant under Lorentz as well as the gauge transformation? So we have to check Lorentz as well as gauge. If any of them are not conjugate, then obviously we will not see the other one. And the gauge transformation has the transformation property as a mu prime equals to a mu plus del mu lambda. Where lambda is a scalar function. So among these 4, we can see only the C option is the correct, where Lorentz invariance as well as gauge invariance are same. So we have just explained these things, each and every terms. And then now question number 3, given the components of the electromagnetic field tensor is given. F0i is equal to minus ei. the component of dual tensor F0 to delta is how much. So we can see here that if mu nu tilde is equal to half epsilon mu nu alpha beta f alpha. So if I just expand this value, this term, then we can get this expression. Where is the expression? Yes. No, not this one. Yes. Half of minus f13 plus f31. So that can also be written as like half of f31 plus f31. That can be fine. Now we have to check that what is f31. So yes, so f31 is 0, 1, 2, 3, and then f31, so 0, 1. So this is minus by. So f31 is minus by, f13 is by, because f mu nu is the antisymmetric tension. So that's why f0 to delta is minus by. Okay. Then question number 4 has that there is a term mentioned, and from that term you have to tell that which one is the correct vector 4 vector potential option, and we got to know that correct option is which one was the correct option? A and D. Okay, A and D both will satisfy the component f10 equals to 0, f20 equals to 0, and f03 equals to minus 4. So how we did that? We just had to write the f mu nu tensor, matrix. Then we write here that E1, E2, Ex, E, Y, Ez value. Then E vector we have already mentioned that 4 is Z cap. Now if E vector is 4 Z cap, then we know that E is minus grad phi minus del T. So from that we will just check that which A combination will give the E vector as 4Z cap or 4K cap. So we got to know that the first one will give the 4Z cap of E, second one will not give, third one will not give, fourth one will give. I think fourth one I have written somewhere. So fourth one will give the correct option. So then we have seen that option number A and D are the correct option for this question. This next question was exactly similar. F10, just the value were different. F104, F204, F03 equals to 0. In appropriate units, which of the following may represent the 4 vector potential? So here we have seen that B and C were the 4 vector potential calculation, like it is the correct option, because we A, B, C, D we have already checked each and every one, and we check that B and C are the correct one. Now coming to the consider the 4 vector potential A mu is this one with epsilon mu and Q mu. So here they were asking that if I0 is there and EI is the real of FI0, then what will be the value of EI? Like E vector. So we checked here that first of all we just wrote all the values whatever it is given. Then fi0 is nothing but del I a0 minus del 0 ai, and a0 is 0, so obviously fi0 will give minus del 0 ai. Then fi0 we have just expanded a little bit, then we got this expression fi0. Now ei is real of fi0, so real of this one. Now there is a trick that epsilon 1 is real, but epsilon 2 is not real. So for epsilon 1, that means E1, we can have this expression, no problem, and there will be the real function, means E1 will be root 2 E0 1 by root 2 sine q dot x. That is fine. That's why E1 is this one. Actually I should not write this one because it is not in the in general case. For E2 case, we have seen that epsilon 2 is negative itself. So if it is negative itself, then not negative, imaginary itself. So imaginary will give us a real one, but this imaginary will make this whole term as imaginary. So if for epsilon 2, this will be imaginary and this will be the real part. So that we have mentioned here. So if I write minus I by root 2, minus I by I root 2 is there. So E2 will be minus E0 cos q dot x, And E3 you can see epsilon 3 is 0, so obviously E3 is nothing. So here, okay, maybe, oh yes, I was there, yes. So E0 sine q dot x I cap minus E0 cos q dot x j cap. So E vector will be E0 sine q dot x I cap minus cos q dot x j cap, because here is a minus sign. So this is the expression. Oh, yeah, I have written this one. Then question number 7 was exactly that one, that delta function calculation. So from the delta function energy momentum conservation, we have seen that either delta for x is equal to delta for minus x. And what is delta for x? This is either the initial momentum sign both have the same positive or both have the same negative, as well as for the final momentum also both have this positive or both have the negative. And obviously both two, I mean initial as well as final will be different sign in front of them inside the delta function potential, delta function. Then this is the expression for the P mu E P P P, where E is its energy and momentum. And they want to know that what is the Dirac equation satisfied by psi. So we got to know that Dirac equation is gamma mu P mu minus m psi equals to 0. And then if I expand that one, gamma 0 P0, gamma I PA. And as it is covariant contravariant, then there will be a minus sign here before. And then you can see that if I expand here, it is gamma 0 P0 minus gamma P1 minus gamma 2 P2 minus gamma 3 P3 minus m equals to psi equals to 0. Then we will just put the values. Then we got to know that gamma 0 E minus gamma 1 P minus gamma 2 P minus gamma 3 P minus m psi equals to 0. So this is the expression. And whatever was the other questions for this assignment, I have seen that whatever the previous year assignment was there, rather than these questions, they were exactly similar, same with this year questions. So that's why I did not mention here these questions. This one was like gamma function properties and all. I mean gamma function property, if you want, if you know, then you can answer these questions. I think two or three questions were there related to like that, like gamma function related to gamma function. And yeah, that is the thing. So let me save first, and after that if you have any doubt you can ask, because I don't know when the internet will go again. So okay, so if you have any doubt you can ask me, or if it is fine then also it is fine. Maybe in between these classes so many internet fluctuation was there for my side, so I'm sorry for that. But obviously you can see the PPT later, so that it will be helpful. And I think these questions are very similar, I mean very simple. So just a little bit mathematics is needed.
Thank you, ma'am.
Yeah, okay, so if there is no other question, then we can stop our session today.
Yes.
Bye.
Thank you. Thank you very
Maybe
much,
we
ma'am.
will meet, I mean, actually this is the extra class. Actually this is not an extra class, this is a swapping of the classes. My class was in Friday, and today I am taking the class because of the other TA was some work. Okay, so no problem, but from next week onwards, the same routine will be there, like I will be in the Friday and he will be in the Saturday. So, yeah, bye-bye.
On Friday, ma'am.
Yeah, like I will be in the Friday because as I
Okay,
was
okay.
there, but this week only it was a little bit swapping. But from next week onwards, it will be same, that I will be in the Friday 6 to 8, and he will be in the Saturday 4 to 6, like that. I mean the previous
Okay, ma'am.
whatever the
Thank you, ma'am.
yes previous routine will be followed. Okay, so bye
Oh,
bye.